Hello, calculus people. Hope you're having a fantastic day today. Today we're going to do the last lesson in this unit, which is over the trapezoid rule. And the trapezoid rule here is a rule that helps us find the area under a curve, much like a Riemann sum. The only difference is that instead of using rectangles, we use trapezoids. And what this lets us do is kind of follow the curve a little bit more, and you'll see what I mean by that here in just a second. First, we have the graph of 1 over x, and it says to compute the integral from 1 to 2, so I'm going from 1 to 2 of 1 over x dx by integration, then approximate using two equal subdivisions, then compare the values. So first I'm going to find out the actual area using integration. Alright, so for integration, remember that we have to integrate 1 over x, and the integral of 1 over x is the natural log of x, natural log of the absolute value of x, and we're going to evaluate that from 1 to 2, which is the natural log of 2 minus the natural log of 1, and the natural log of 1 is 0, so I can get rid of that. So the area under the graph between 1 and 2 is the natural log of 2. Alright? Now, this is approximately, if you grab your calculator and type that in, it's approximately 0.693. Right? And that's just me going over here and typing in the natural log of 2, 0.693. So that's the actual fitted area. That's the entire area under this curve. So let's talk about sums now. Now remember, if I have, they're all going to be split up between 1 and 2, right? I'm not going to connect them up to the graph just yet, but let's do a left-hand sum first. So a left-hand sum with two subdivisions. Alright, so the distance for each, my delta x here, the distance for each rectangle is 1/2. And then it's, for left hand, it's f of 1 plus f of 1.5. Alright. So this is going to be 1/2. And f of 1, if you plug a 1 in, remember, your function is 1 over x, so if you plug a 1 in, 1 over 1 is 1, or excuse me, wait, what am I doing here? Yeah, okay. Plugging in a 1, we get 1 over 1, which is 1, plus 1 over 1.5. Alright, and I have this, this already pre-calculated just for time. It's going to be 0.833. Now what about a right-hand sum? A right-hand sum with two subintervals, and that's going to give me, again, my space of the rectangle is 1/2. This is my delta x. How wide is each rectangle? Now right-hand sum will be 1.5 and 2. F of 1.5 plus f of 2, which is 1/2. Again, plugging in the 1.5 for x, I get 1 over 1.5 plus 1 over 2, and that is 0.583. Now you can already see how a left-hand sum here, if it was going up to the left-hand side, it would be an overestimation because the function is decreasing here. The right-hand sum would be underestimation because it's decreasing. So the midpoint sum should be somewhere in the middle of that. Midpoint sum of 2, 1/2, again 1/2 being my delta x here. 1/2 of, now I have to go to the middle of 1 and 1.5, so this will be 1.25. Plus, and the middle of 1.5 and 2 will be f of 1.75. So I have 1/2 And this will be, well, here, let me just do it this way. I have the final answer here. Let me just write it out. It'll be 0.686. If you go through and you put 1.25 over 1, that's 5/4 over 1, which would be 4/5. 1.75 is 7/4, which 1 over 7/4 will be 4/7. It's a mess, but that's okay. And then remember, the midpoint sum means that the middle of the rectangle is what's touching the graph. So we've got some underneath and some on top of the graph. Now here's where the trapezoid rule comes into play. If you'll recall, the area of a trapezoid is 1/2 your height of the trapezoid, which in this case I'm going to call height my delta x. Remember, it's the horizontal height, I guess you could call it. And then your bases are the vertical stretches here. So then it's base 1 plus base 2. These are your y values. Now I want you to go up here to this picture. I'm going to zoom in here so you can really see what's going on. And what I've got is a trapezoid to come up here and build onto this graph. Hopefully you can see where this will be a lot more accurate. So there's my trapezoid. And there's my trapezoid. So see, instead of using rectangles, I use trapezoids, and the top of the trapezoid, instead of being a flat rectangle, is going to bend sort of with the curve. So obviously the more trapezoids we would have, the more accurate it would be. So this is how we're going to use the trapezoid. Now remember, with rectangles, well, never mind. I'll get to that in a second. Let's go down here to our trapezoid rule. So I'm going to use the trapezoid rule with two trapezoids. And the first trapezoid, it's going to be 1/2 times my delta x, which is 1/2. So I've got 1/2 times 1/2. And base 1 and base 2, so the first one will be f of 1 plus f of 1.5. This is my first trapezoid. F of 1, f of 1.5. Whatever f of 1 is will give me this height. F of 1.5 will give me this height. So the next one then is 1/2 times delta x, which is 1/2. Remember that 1/2 will always stay the same. Delta x will change from question to question. And then base 1, base 2, those are the heights, or excuse me, the y values of the function. So for this one, I need f of 1.5 and f of 2. Okay. So let's simplify this down just a little bit, because this has the potential of getting a little complicated. T2. They both have two 1/2s I can take out. So let's factor out that 1/2. Both 1/2s out of both of them. And then if you notice, what I'm left with then is f of 1 plus f of 1.5 plus f of 1.5 plus f of 2. So pull the 1/2 and the 1/2 out. Yeah, we're going to multiply them together and call them 1/4. But what I want you to focus on for just a second is the fact that f of 1.5 is doubled. Why do we have two of these? Well, if we're using trapezoids, I'm going to need to cover this height and this height for this first trapezoid, and then this height and this height for the second trapezoid. So all of the middle pieces here, I'm going to need to cover twice. Alright. Now we already have most of these from the beginning part, so f of 1 is 1 plus 1.5 is 1 over 1.5. F of 1.5 is 1 over 1.5, and f of 2 is 1 over 2. And that is approximately 0.708. Now, what's interesting about the trapezoid rule is that if you average the left and right hand sums, you get the same thing. If I was to take my left hand sum plus my right hand sum and divide it by 2, I would get 0.70 blah blah blah. These two things are the same. That means that the trapezoid rule is an average. The trapezoid rule is an average area. And the key to doing the trapezoid rule is to understand that these 1.5s, f of 1.5s, are doubled. Now, obviously there is a form to this, and we're not going to have to come up with the trapezoids every single time. There is a slightly shorter way to do it, and it's just from simplifying. It comes on the next page. Alright, let me back up here. So the trapezoid rule. To approximate the integral from a to b using the trapezoid rule, we have 1/2 b minus a over n. This guy right here, this is delta x. And then y, 0, which is your first y, plus 2 times your second y, plus 2 times your third y, all the way up to yn. Notice that these guys here are doubled. These are all of your middles. You're going to double the middle values. Okay? All of the middle values of your trapezoids, because you're going to have to use them twice. If you have 4 trapezoids, you've got one here, one